Hi, this is Open Up Resources, Algebra 1, Unit 1, Lesson 4, Scott's Workout. The learning focus for this one is modeling a sequence using a table graph and explicit and recursive equations. So kind of how do I see the change between the figures in each representation? How can I tell if the sequence is arithmetic or geometric or neither? How are explicit equations different than recursive? Excuse me. What are the advantages of using an explicit equation versus a recursive equation? So those are kind of the things we're going to be looking at as we're going through it today. All right, Scott has decided to add push-ups to his daily exercise routine. He's keeping track of the number of push-ups he completes each day in the given bar graph, with day 1 showing he completed 3 push-ups. After 4 days, Scott is certain he can continue this pattern of increasing the number of push-ups he completes each day. So how many will he do on day 10? So here we're looking at, again, I'm going to do my pictures. So 1 has 3. First day he does 3 push-ups. The second day it looks like he's doing 5. The third day, 7. The fourth day, 9. So if we keep going on here, I'm noticing it's a +2 on each of these. So if I go ahead and just kind of do a table, 5, 6, 7, 8, 9, 10. So on 5, he'll do 2 more, which is 11. 6, he'll do 2 more, 13, 15, 17, 19. That puts him at 21. Okay, so that's one way we can figure that out. Model the number of push-ups Scott will complete on any given day. Include a table, a graph, and both recursive and explicit equations. Looks like my graph did not copy on here, so we'll just have to make do on here. So we have days, we have push-ups. 2, 3, 4, 5. So on day 1, he did 3, 2, 5, 3, 7, 4, 9, 5, 11. So we were saying how this was a +2 on here, right? So I'm going to let's do our graph. We'll just do our own graph here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. And 7 got up to how many? 15. Okay. So 2, 4, 6, 8, 10. Oh, they're all odd numbers. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's good that we have some markings on there so we know how much we're jumping by. All right. So 1 was 3, 2 was 5, 3 was 7, 4 was 9, 5 was 11. So we can kind of see, I don't have my good lines on here, that we go in pretty much a straight line. So that means it's going to be we'll get to that in a minute. Won't give away the secret. All right, so my recursive equation. Let's start with what my f of what we start with. 1. My first term is a 3. So I want my next term is going to be my previous term. And then what are we repeating over and over? +2. So when we turn this into the explicit equation, my output is, what is my, let me do my table again over my list. So my first one is 3. 2 is the 3 plus 2. 3 is the 3 plus 2 plus 2. 4 is the 3 plus 2 plus 2 plus 2. So what I'm noticing, when I have 2 here, I only have 1 here. 3 here, I only have 2. 4, 3. So it's the same idea as that ready for more that was on the last lesson. I need 1 less. So my 3 is the constant right here, right? And then I'm going to add 2. Try to keep my colors good. Plus 2, but it's not going to be to the n because I don't need 2 n's, I only need 1. So I want to the n minus 1. So I need to have that constant. What's constant every time and what's changing, this time it's not the term number, it's the term minus 1, term minus 1, term minus 1. All right. So now, what type of sequence is our model? Well, we are adding each time to each time. So this is an arithmetic sequence. That is how we know as well. So let's go ahead and, again, we'll jump to the takeaways and then we'll come back for the ready for more. So our takeaways, finding the common difference in each representation of an arithmetic sequence. So how does the table help us do this? The table, we can find the difference between terms. Our explicit equation is our f of n equals, we said our constant this time was 3, and then we added 2 each time, but it wasn't as many 2's as the term number, so we had to take 1 away. That means our recursive, I didn't draw for this one. We'll go ahead and I'll just put this one all in purple here. So we started with f of 1 was 3. F of n, our current, is our previous plus 2. So we need both of those to make this work. And our graph, what helped us with that was straight slope was 2. So that 2 is also our common difference on there. Recursive notation we did above. So I'm going to go ahead and just draw that arrow right there. They have that one twice really in my book. So those are kind of the takeaways for this one. All right, let's look at this ready for more. Allie is also including push-ups in her workout and says she does more push-ups than Scott because she does 15 push-ups every day. Is she correct? Explain. Well, if she does 15 every day, is she doing more? Well, Allie's table would just be 15 to 15. So at the start, she's doing more, 15, etc. But if we go back up to Scott's, by day 7, he's doing 15. But look what he's doing after that. He's going higher. So really on this one, what we would say is Allie does more push-ups the first 6 days. They both do 15 push-ups. Day 7, But then Scott does more push-ups each day after that. So Ellie does to start with. And then after that, Scott's ahead of her. Nice try, Ellie. All right, retrieval. Let's make sure we know what we're doing for our retrieval. Okay, use the explicit function equations below to find the indicated values. So here, go ahead and do this one. So I'm going to substitute a 2 in for x. 6 times 2 plus 5, that's 12 plus 5, which is 17. The next one, I'll do a negative 2. Then I switch colors. Negative 2 for that. 6 times negative 2 plus 5, that's negative 12 plus 5, which would be a negative 7. All right, next one. Substitute in a 4. So 3 to the 4th power, that'd be a 3 times 3 times 3 times 3. So that's 9 times 9, which is 81. And now we're throwing in a 0. 3 to the 0. Anything to the 0 power is always 1. Next. For problems 3 through 5, use the graph to answer the questions. The graph is a sketch that was created to represent the distance traveled by a biker over time. Okay, so how far away are they at 0.5 hours? So here's 0.5-ish. And, 0.5 hours. Look at my labels. This is distance. So 0.5 hours. Can't quite see the little lines on there. 1, 2, 3, 4. Okay, so probably looks like maybe 0.1 miles. Like it's pretty close on there. Time in hours. Okay. I don't know if I can. Okay. Next one. How long does it take them to reach 2 miles away? So, 2 miles doesn't even go to 2 miles. But I think they got these labels switched, because that does not work for us. I'm going to make an executive decision and time, hours, and this one is distance in miles, because those don't make sense with how they're asking the question. So let's go try this again. All right, so 0.5 hours would be right here, which puts us at about 8 miles away. How long does it take them to reach the 2 mile mark? So 1, 2 is about right there. Takes about 0.2, 4, 6, 8, 10, about 0.25, I'm going to say. 0.25 hours, or that would actually be 15 minutes, right? Okay. Which of the variables is represented by f of n? Okay, so I think their labels are wrong, just the way they were doing this stuff. So, time or distance. F of n, this is going to be your n, this is going to be your f of n, so our distance right here. All right, a couple more. Find the slope for each given representation. Well, this is y equals mx plus b form. M is the slope, so slope equals 8. in this case. Oh, for this one, we have to change in y over change in x. So let's do our y's first. So negative 11 minus 5 over, now let's do our x's. I got to start on this side, so 6 minus a negative 2. So that means it's negative 16. 6 minus a negative is a positive over 8, so that's a negative 2 slope. And last one, let's see, we're going up by ones, plus 1, plus 1, plus 1. So we have our rise over run. So this is a plus 4, plus 4, plus 4. So our rise is 4 over 1, which equals a slope of 4. That's all for today. Thanks for joining us, and we'll see you next time.